Okay, so we want to start with these questions in 11.1, dealing with three-dimensional coordinate system. First problem is we're finding the distance between 2 points in three-dimensional space. So to do that, we're going to use the distance formula. There it is. We can just remember, we get x1 minus x2 squared plus, now we're subtracting the differences in the x-coordinates. Sometimes you'll see this as x2 minus x1 squared. There's going to give you a negative of what we have here of x1 minus x2. Once you square this, that negative is going to go away. So this x1 minus x2 squared is the same thing as x2 minus x1 squared. So you may see either notation. And then we'll get plus a y1 minus y2 squared plus a z1 minus z2 squared. Again, you could replace z2 minus z1, replace z1 minus z2 with z2 minus z1. Now, we need to talk about what x1, x2, y1, y2, z1, and z2 are. Well, those are just the x, y, and z coordinates of our points. So it's going to turn out here that x1, that's the first coordinate of the first point. So the x coordinate of the first point. That's our 5. So what we get, here's x1 is 5. x2, the 2 denotes the second point, and it's the x coordinate. So that's going to be this 0 here, second point here, and we'll do our x coordinate is 0, square, plus the difference in the y coordinates. So the first point has a 12. The second point has a 2 in the y coordinate. And then the z's, first point has a -3, second point has a 4. And we just have to do the arithmetic here, and we get, let's see, 5 minus 0 is 5 squared, 12 minus 2 is 10 squared, -3 minus 4 is -7 squared. Again, if you'd done this as z2 minus z1, you'd get 4 minus -3, and you get a positive 7 there. Now, when you square, -7 squared is 49, same thing as 7 squared. So it didn't really matter what order you did that. So we end up with square root of 5 squared is 25, 10 squared is 100, -7 squared is 49. Okay, so we add up the 25 plus 100 plus 149. That gives us a square root of 174, which doesn't work out to be a perfect square. So our answer here is square root of 174. Now for problem 2, straight mark there, we want to look at the sphere equation x minus 5 squared plus y plus 2 squared plus z minus 3 squared equals. Now the center, we just need to read this off. If the center, it's going to, well, let's just do the equation of the sphere here. So our sphere equation is x minus x naught squared plus y minus y naught squared plus z minus z naught squared, and that should all equal the radius squared. Now if you look at this, you should have x minus something squared, so that tells us our center, whoops, don't know what's going on there. Click that. So our center has x coordinate of 5. So again, you've got the x naught, that should be 5. Now the y coordinate, we're going to have minus something. So plus 2 is the same thing as subtracting -2. So it's really y minus -2. The z coordinate is the 3. So there's your center of that string. And then the radius, we just use this formula again. 9 is 3 squared. So the radius, or r, that just equals 3. Okay, so there's problem 2. Okay, problem 3. We've got a sphere equation like this, same thing as before. We have an equation, find the center and the radius of the sphere, but now it's not given to us in that form of x plus or x minus something squared. We have to create that ourselves. So the first thing I'm going to do is group the x terms on the left together, the y terms together, and the z terms together. So I'm going to get is x squared plus 4x plus y squared plus the 12y, and then plus z squared, and then it's minus 8z, and that equals 62. Now I need to complete the square for both the x part and the y part and the z part. So in the x part, what I'm going to do is I'm going to do x squared plus 4x. I'm going to think half of 4, that's 2, and then I'm going to square 2. That gives me 4. I'm going to get there. I'm going to put this in parentheses just for my own sake of seeing how things work later on. I might also end up having an equals 62 here. I'm going to have to add that 4. Because I added the 4 here, I have to add the 4 on the other side as well. Otherwise, I'm changing the left-hand side and not the right-hand side of the equation. Now with the y's, I'm going to get y squared plus 12y. Then we need to add, and what's going to happen is we want to have half of 12 is 6. I'm going to do 6 squared, that's 36. So I need to add 36 on the right as well. With the z's, half of 8 is 4. 4 squared, or maybe half of negative 8 is negative 4, but negative 4 squared is positive 16. So I need to add 16 as well. Now, the point of adding the 4, the 36, and the 16 is each of the x part, the y part, and the z part should factor as a perfect square. So this is now x plus 2 squared. It's half, sorry, no, it's the square root of the 4. It should be the same thing as the half of this 4. Plus, y half of the 12 is 6, so this should be a y plus 6 squared. 6 squared gives me the 36. And the z part is z minus half of the 8 is a 4. 4 squared is 16. And now over here I get 62, let's see, plus 4 is 66, plus 36 is 102, plus 16 is 118. Do that correctly. Yeah, looks good. Okay, and so my center, so we're back in like problem 2's form here. Center, it's just what's subtracted from the x for the x coordinate. That's really minus 2, so we're adding 2, so I think it's subtracting negative 2. For the y, it's negative 6. For the z, it's 4. So there's our center. Whoops. The radius of the sphere, well, that's going to be square root of 118. Whatever that happens to be, that's not going to be a perfect square. So it's something a little bit up. Okay, now I want to look at number 4 here. So here we get another sphere equation. We find the center radius. So this should be very much like the last problem, except there's another twist. Here are x squareds, are y squared, z squared, all of the same coefficient, which is 3. So the first thing I'm going to do is divide both sides of this equation by 3. That is, I'm going to divide every term by 3. So step 1 is I need to get rid of that 3. So I end up with x squared plus y squared plus z squared minus 12 divided by 3 is 4x minus 6y plus 3z, and divide the 81 by 3 as well. That gives you 27. Now I do the same thing as before. I'm going to get x squared minus 4x. Half of 4 is 2, squared is 4, plus y squared. We have the minus 6y. Half of 6 is 3, 3 squared is 9, plus we have the z squared plus 3z. This one's a little bit weirder. Half of 3 is 3 halves. That squared gives us 9/4. And then on the right, we have the 27, and then we have to add each of these constant terms. We just sort of add it along. So we get plus 4, plus 9, plus 9/4. And then we factor these really as x minus 2 squared plus y minus 3 squared plus z plus 3 halves squared. No, half of 3 is 3 halves. 3 squared is 9, 2 squared is 4. And we get, let's see, 27 plus 9 is 36, plus 4 is 40, plus 9/4. So let's just go up here and say 40 plus 9/4. That's 160 fourths plus 9/4. So 40 times 4 is the 160. So that should be 169 fourths there. And so our center, that's what we're asked for in part A, well, that's going to be the -2, so it's the 2. The y is -3, so it's 3. The z, we're going to get a -3/2. So there's our center. And the radius should be the square root of 169 over 4. So the squared part, or the part over here, and then we take the square root. So the 169 over 4 should be r squared. And both 169 and 4 have nice square roots. So we get radius as 13/2. Okay. One more set of questions here. So 5 here. So I'm going to write inequalities to describe the region. So I'm going to talk about the region between the xy plane and the plane z equals 4. So we're talking about an inequalities to describe the region between two planes. Now, one thing that we want to notice here is that xy plane, it's going to be where sort of x and y can vary and z is fixed. That's really z equals 0. So when you think about this, you really have the z values going between 0 and 4, and so our answer is just z goes between 0 and 4. I'm not going to get too concerned about whether we have less than equals or less thans here. It may matter in some technical situation, but that's not really specified here. I suppose between, I might think about less thans, but do I include the endpoints or not? End planes. B, I'm going to be inside the cylinder x squared plus z squared equals 7. So again, when I square two of the variables, but not the third, that's going to give me a cylinder. So when I'm inside, that's going to be a less than or equal to. So I get x squared plus z squared. Equal would be sort of on the outside of the cylinder. Less than puts me on the inside. And then I'm going to be between the planes y equals -2, y equals 5. Note there's no y's over here, and so we can just write down our other inequality, -2 less than equal to y, less than equal to 5. So that pair of inequalities describes that region. Okay. Now again, we've got two parts to this. First part is outside the cylinder. So outside, it's going to be the y squared plus z squared is actually going to be greater than or equal to 9. Inside the sphere, it's going to be x squared plus y squared plus z squared. If we're inside, for a sphere, it turns out to be less than or equal to 16. Outside, inside, and that is our answer there. And that should complete this worksheet.